Hello friends, the new case is from the chapter probability, that is, a bag contains 8 black, 3 red and 9 white balls. If 3 balls are drawn at random, find the probability that number 1 or A is all are black, that means all 3 are black. Number 2 or B, 2 are black and 1 is white. Number 3, 1 is of each color, and number 4, none is red. So the case is 3 balls are to be drawn out of 20 balls. First of all, in how many ways 3 balls can be drawn out of 20? 3 balls out of 20 can be drawn in 20C3 different ways, and they are mutually exclusive. 20C3. What is the value of 20C3? It is 20 factorial upon 3 factorial into 20 minus 3 factorial. That means 20 into 19 into 18 into 17 factorial. Why 17 factorial? 3 factorial into 2 into 1 and into 17 factorial. So we can cancel these two 17 factorial against each other. 3 can be cancelled against 18 by 6. 2 can be cancelled against 20 by 10. So the answer is 10 into 19 into 6, that is 1140 or 1140. This number 1140 is actually total number of possible outcomes if we draw 3 balls at random out of 20. Now the first sub question is all are black. That means we need to find the probability of all, that means all 3 are black balls. Now we have total 8 black balls out of 3, rather out of 8. If all 3 come, then there can be all the 3 black balls. So the case, or rather the required probability is 8C3, that is favorable number of outcomes for getting or drawing 3 black balls out of 8, and total number of outcomes 20C3. Now we have simplification of 20C3. Let us take 8C3, that should be 8 factorial upon 3 factorial into 8 minus 3 factorial. That means 8 into 7 into 6 into 5 factorial divided by 3 factorial is 3 into 2 into 1 into again 5 factorial as it is, so that we can cancel them. 3 and 2 both can be cancelled against 6. So the answer is 56. That means out of 8 balls, 3 can be drawn in 56 ways. So the required probability or probability of all the 3 black balls is 56 divided by 1140. And we can divide all these two numbers by 4. It will be 14 divided by 285. Or you can calculate the decimal value also. The sub question 2 or B is, what is the probability that 2 are black and 1 is white? That means probability of 2 black and 1 white ball, or drawing this type of balls, but in all there must be 3 balls. That means in this case 2 black should be drawn out of 8. That is 8C2, and means multiplication, 1 white out of 9. The number of cases for that can be 9C1. 9C1 is 9 itself, but what is 8C2? Let us get the answer. 8C2 equals to 8 factorial divided by 2 factorial into 8 minus 2 factorial. That means 8 into 7 into 6 factorial, because we are going to get 6 factorial as a denominator too. 2 into 1 into 6 factorial, and both are cancelled. 2 can be cancelled against 8 by 4. The answer is 4 into 7, 28. Yes, there is a very short formula to remember to get the answer of NC2. What is the answer of NC2, or what can be the answer of NC2? N into n minus 1 divided by 2. That will give you the answer without any working on paper or anywhere else. Just practice on it. It is 28 into 9C1 means 9 divided by 20C3 means 1140. Let us multiply 28 with 9. The result is 252 divided by 1140. What can be the simplified version of 252? Both can be divided by 4. So here also we divide both by 4. The answer is 63 divided by 285. The third case or the third sub question is one of each color. What is the probability that one of each color? As we know, we have decided to draw 3 balls out of 20. Now, what is the probability that all the 3 are of each color? Okay, C or 3, probability 1 of each color. That means probability that 1 is black and 1 is red and 1 is white. 1 of each color. 1 black means 1 out of 8. 8C1. And means multiplication. 1 red means 1 out of 3. Again multiplication because of and. 1 white means 1 out of 9. That is 9C1. So favorable cases or number of favorable cases will be 8C1 into 3C1 into 9C1. 1 of each color. Divided by 20C3. 8C1 is 8. 3C1 is 3 and 9C1 is 9 divided by 1140. 8 into 3 into 9, that is 216 divided by 1140. Again we can divide these two numbers by 4, so the result will be 54 divided by 285. This was comparatively a very simple case. Now the fourth sub question is none is red. That means out of 3 there should not be any red. That means there is no restriction of other 2 colors. Any combination of number of balls from other 2 colors is allowed. But the condition is there should not be any red one. Now out of 20 only 3 are red. That means remaining black and white balls are 17. Any combination out of these 17 is allowed. So the fourth case is probability of none is red. That means if 3 balls are drawn out of 20 in this combination, no one out of 3 should be red. That means any combination out of remaining 17. So the favorable cases will be 17C3 and as we know the total number of cases 20C3. Let us get the answer of 17C3. It must be 17 factorial upon 3 factorial into 17 minus 3 factorial. 17 into 16 into 15 into 14 factorial divided by 3 factorial means 3 into 2 into 1 and into 14 factorial, that is 17 minus 3. Cancel 14 factorial. 3 can be cancelled against 15 by 5 and 2 can be cancelled against 16 by 8. 5 into 8 40 into 17 680. So favorable number of cases for this type of event 680. So the probability or required probability is 680 divided by 1140. Let us cancel the two zeros. Can we divide these two numbers by 4? No, but we can divide these two numbers by 2. So the final answer of the required probability is 34/57. Okay, thank you.